of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
Our current knowledge of the cosmos reveals a captivating tale. 13.8 billion years ago, the universe burst into existence from an unimaginably hot and dense state. In an instant, space expanded, matter cooled, and the fundamental forces of nature began to take shape, setting the stage for the ongoing cosmic drama. This extraordinary event marked the birth of the very elements that form galaxies, stars, planets, and all that has existed or is yet to come, including ourselves. The quest to comprehend the universe's origins not only deepens our scientific understanding, but also confronts profound existential questions about reality and our place within the grand tapestry of the cosmos. While theories and simulations strive to unravel the nature of this primordial genesis, our observations are limited by the relentless expansion of the universe. Hence, grasping the birth of the first monumental structures that emerged shortly after the Big Bang becomes pivotal in dissipating the fog surrounding our beginnings. This is precisely why the James Webb Space Telescope was meticulously crafted to explore the early universe in the aftermath of the Big Bang. Already, it has unveiled perplexing mysteries that challenge astronomers. The latest revelations from Webb have shattered preconceived notions about the appearance of early galaxies. Astronomers long believed that these infant systems would resemble spherical orbs or flat disks, akin to their modern counterparts. However, the telescope's new images have astounded researchers by revealing something far stranger. These nascent galaxies bear an uncanny resemblance to bananas. Astonishingly, this conclusion comes after a meticulous re-examination of 4,000 newborn galaxies captured by Webb at the dawn of time. Should these findings stand the test of scrutiny, they possess the potential to revolutionize our comprehension of the intricate processes governing the birth and expansion of galaxies. Furthermore, they offer tantalizing clues about the enigmatic properties of dark matter, a mysterious and invisible substance that is thought to constitute a significant portion of the universe. The James Webb Space Telescope's revelations not only challenge our preconceptions, but also beckon us to embark on a thrilling journey of discovery where the universe's secrets await those who dare to explore. What adds an intriguing layer to this discovery is the resistance it faces from many astronomers, despite building upon earlier hints from the Hubble telescope, which had also suggested that the earliest galaxies took the shape of pickles. One scientist, Dr. Alan Dressler of the Carnegie Observatories, who played a pivotal role in the development of the James Webb Space Telescope, remains skeptical about these findings, although he was not directly involved in this particular observation. I retain some skepticism about this result, given how hard it is to make such a measurement, especially for galaxies that are far away, small, and not very bright, he expressed. Nonetheless, the team delved into the investigation of galaxies' three-dimensional shapes by statistically analyzing their two-dimensional projections in the sky. If these primordial galaxies were spherical or disc-shaped and positioned randomly in space, astronomers would expect them to occasionally present their complete faces, appearing round and circular when observed through telescopes. However, the observed data deviates from this anticipated pattern. Instead, astronomers are consistently encountering an abundance of shapes resembling cigars and bananas. They consistently look very linear, explained Dr. Panya, the study's lead author, with some galaxies exhibiting multiple bright clumps arranged like pearls on a necklace. These elongated galaxies are a rarity in the present universe, but they make up a remarkable 80% of the galaxies within the cosmic evolution early release science sample, which extends back to approximately 500 million years after the Big Bang. The masses of these peculiar galaxies indicate that they could be the ancestors of galaxies like our own Milky Way, suggesting that our galaxy may have undergone a similar phase of elongation or surfboard-like morphology in the past. In the modern universe, galaxies predominantly assume two basic forms: featureless, rounded clouds known as ellipticals, and flat, wispy disks like our Milky Way. Evidently, these earliest newborn galaxies did not begin their cosmic journey in such familiar shapes. Back in 1926, Edwin Hubble devised a classification scheme known as the Hubble sequence that segregated galaxies into three categories: ellipticals, lenticulars, and spirals, based on their appearance. Cut to the recent present, and in 2010, a team of European astronomers, using data from the Hubble Space Telescope observations, created a census of galaxy types and shapes from a time before Earth and the Sun existed, up to the present. The team sampled 116 local galaxies and 148 distant galaxies. The results showed that the Hubble sequence 6 billion years ago was very different from the one that astronomers see today. 6 billion years ago, there were many more peculiar galaxies than now, which was very surprising, and which also meant that in the last 6 billion years, these peculiar galaxies must have become normal spirals, giving us a more dramatic picture of the recent universe. The astronomers think that these peculiar galaxies became spirals through collisions and mergers. Although it was commonly believed that galaxy mergers decreased significantly 8 billion years ago, the new result implied that mergers were still occurring frequently after that time, up to as recently as 4 billion years ago. This study also reiterated that spiral galaxies are indeed young galaxies that have not been around for a very long term as compared to other types of galaxies. Now cut to the present, and we have the James Webb Space Telescope that is taking our cosmology for a spin, and its latest finding is another blow to our understanding of the universe. The standard model of cosmology suggests that galaxies evolved over time. They formed from vast clouds of primordial hydrogen and helium, and so likely had a fairly amorphous structure at the beginning. Given the density of the early universe, galactic collisions and mergers were common, which gave galaxies their rotations and caused them to form disks and spirals. All of this takes time, so we would expect spiral galaxies to be fairly common in the local universe, but rare in the early universe. Now, a team of scientists has used data from the Cosmic Evolution Early Release Science Survey, which was gathered by the James Webb Space Telescope. They identified 873 galaxies greater than 10 billion solar masses with redshifts between 0.5 and 4. Galaxies at this redshift are between 5 billion and 12 billion years old, so they span the range of early galaxies to modern ones. Of these galaxies, 216 were classified as spirals. The researchers were careful to note that some may be merging galaxies that were misclassified, but even then, 108 of the galaxies were unanimously classified as spirals by evaluators. When the team arranged them by redshift, they found that while the fraction of spirals decreased as you went further into the past, the fraction of spirals at redshifts above Z equals to 3 was much higher than expected. A redshift of Z equals to 3 is around 11.5 billion years. When the team calibrated observations, they found about a fifth of galaxies at Z equals to 3 are spiral galaxies. These very early galaxies would have had to become spirals less than 2 billion years after the Big Bang, meaning that there would have been little time for mergers and collisions to be the cause. In other words, many galaxies evolved into disc-shaped spirals quite early in the universe. So while collisions and mergers do play a role, in the formation of spiral galaxies, there are likely other factors that come into play. In the quest to unravel the mysteries of the cosmos, the James Webb Space Telescope has emerged as an unprecedented tool, defying expectations and challenging our understanding of the early universe. Its groundbreaking findings have captured the imagination of astronomers and sparked a cosmic curiosity that knows no bounds.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Look at this image. What you see here is a very distant cosmic structure shining brightly in the early universe. But the discovery of this bright object has solved a long-standing mystery of astronomy, because our current understanding of the universe says that our universe came into existence about 14 billion years ago, and after the Big Bang, the universe went through a period of complete darkness called the Dark Ages. This was the time when the universe was filled with clouds of gas everywhere. Even if we built the most powerful telescope ever built, we wouldn't be able to see beyond the Dark Ages. But for decades, scientists have been noticing that some strange light was coming from the dark clouds. A serious discovery has sparked debate among astronomers. Recently, for the first time, the Webb telescope observed two ancient galaxies. Intriguingly, these galaxies seem distinct from those familiar to us, prompting questions about their origin within our universe. Such discoveries of Webb telescope have raised some big questions. Are we wrong about the age of our universe, or are we wrong about the origin of these galaxies? So, what are these strange lights, and where are they coming from? Well, new discoveries from the Webb telescope have finally revealed this mystery and conclude that what we previously thought about the early universe may need to be revised. This new Webb telescope image revealed that this light is actually a rich source of Lyman alpha emission. This image shows that there were more galactic mergers in the early universe than we could see before the Webb telescope got going. Those mergers and interactions and the abundant star formation that they spawned are responsible for both creating the Lyman alpha emissions. But scientists previously believed that these emissions should have been blocked by the dense hydrogen clouds that filled the space between galaxies during the Dark Ages, and we should not have seen these emissions. But we are seeing it. Well, researchers recently revealed that as stellar mass gathered and stars formed in these early galaxies, two things happened. The stars emitted Lyman alpha emissions, and they created bubbles and channels of ionized hydrogen in the light-blocking neutral hydrogen gas. The bubbles and channels allowed Lyman alpha emissions through, so this shows that the stars could detect objects beyond the Dark Ages. And surprisingly, in another recent deep field image, scientists found two galaxies that existed beyond the darkness of the early universe, and scientists are now saying that these galaxies are not like the ones we have seen. On the other hand, both of these galaxies are highly red-shifted, and astronomers claim that this would be a serious problem if these objects are indeed galaxies. This graph representation provides a comprehensive overview of distant galaxies as seen through the remarkable capabilities of the Webb telescope. Here we can see the farthest galaxies confirmed through spectroscopic observations. One of them, named GNZ 11, lies approximately 13.2 billion light-years away and was initially spotted by the Hubble telescope. A recent image from the Webb telescope has revealed something extraordinary in this galaxy. Astronomers have identified a supermassive black hole at its center. This finding establishes it as the most distant black hole on record, forming just 400 million years after the Big Bang, challenging our understanding of black hole formation due to its enormous size. Scientists are saying that the size of this supermassive black hole does not fit with the time period of the universe because the death of the first stars or the merger of black holes in the early universe cannot create such a large black hole. We need a completely new way of thinking about the formation of these massive black holes so early in the universe. But wait, there is something else in this data that has shocked astronomers around the world. Well, as we can see, these galaxies are the most distant galaxies discovered by the Webb telescope, and the red signs indicate that these galaxies have already been confirmed from spectroscopic observations. So the most distant confirmed galaxy right now is named GESZ 13-0, which existed about 13.47 billion light-years away. There is something more to this data. Here we can see the two most distant galaxies located at a redshift of around 16. This means that these galaxies existed beyond the Dark Ages. This is surprising because our standard cosmological models say that galaxies first formed at the end of the Dark Ages. But here we can see massive and strange galaxies that existed beyond the Dark Ages. This discovery shows that galaxies were formed much earlier than our theories had predicted. The problem now is, how do we explain the existence of these galaxies? One way we might think is that our universe may be much older than we thought, or that there is a possibility that something strange may have happened after the Big Bang that accelerated the formation of early galaxies. Well, spectroscopic observations of both these galaxies are yet to be made. But if spectroscopic observations confirm their predicted redshifts, the basic foundations of cosmology will be shattered. Well, there is another hypothesis which have recently become popular among scientists, which we know as the conformal cyclic cosmology. This cyclic universe model may explain the existence of these strange early galaxies. Nobel laureate Dr. Roger Penrose says that there was a universe before us which he refers to as the previous eon, and that black holes evaporate at the end of the previous eon as predicted by Stephen Hawking, and the evaporated energy from that black hole gives birth to the Big Bang of the next eon. He also postulates that dead black holes from the past universe accelerated the expansion of our early universe. Scientists believe that these dead black holes from the past universe may explain the existence of supermassive black holes and huge early galaxies in the early universe. Well, everything the Webb telescope has discovered so far poses a challenge to our understanding of the universe. It's no surprise that even in just its first 3 years of science operations, that JWST has broken a slew of cosmic records, including records for most distant galaxy, most distant protocluster of galaxies, most distant black hole, most distant red supergiant star, most distant gravitational lens, and most distant quasar. These findings suggest the possibility that our universe might be much older than initially believed. Alternatively, it could be part of a chain of interconnected universes, or it might have always existed without a definite starting point. Considering the apparent infinite size of our universe, the idea of its age being infinite becomes plausible. The conventional concept of the Big Bang may just be a specific moment in the ongoing evolution of this perpetually existing causal set, rather than a true beginning. Finally, if you guys have finished this video, don't forget to comment what you think about these discoveries and what you think about the age of our universe.